At some point in your life, you've probably been on a form of public transportation. It might have been on a bus, metro, train, plane, or even something else. Often we share these rides with other people. From your point of view in the vehicle, these people are sitting or standing still. However, to a bystander standing still outside the vehicle, you and your fellow passengers are moving at a faster velocity. We can call these 2 points of view 2 different frames of reference. In physics, we can classify frames of reference by 2 main types, inertial and non-inertial. Inertia is the property of matter in which an object that is at rest wants to remain at rest, and an object that is moving wants to remain moving in a straight line unless another force acts upon it. Likewise, an inertial frame of reference is a reference frame in which an object stays either at rest or at a constant velocity unless another force acts upon it. When a body does not seem to be acting in accordance with inertia, it is in a non-inertial frame of reference or accelerating. Newton's first law states that a body at rest will remain at rest, and a body in motion will remain in motion at a constant velocity in a straight line unless acted upon by an external force. The external force in this law being a force that does not originate from the body itself. Looking at the previous definitions for inertia and an inertial frame of reference, we can see that their definitions are almost the same as Newton's first law. Another way to define an inertial frame of reference is a frame of reference in which Newton's first law remains true. So then you might be wondering, when could Newton's first law ever not appear to be true? Well, you've actually probably experienced a time when it doesn't seem true yourself, and it has to do with non-inertial frames of reference. Let's think back at our example of the bystander outside a vehicle and the passenger inside from the first section of the lesson. I'm going to change the example a little bit first. For one, we will simplify it down to one passenger inside the vehicle. Secondly, let's imagine the vehicle the passenger is in is a soundproof box he or she cannot see out of. This way, the passenger will have no way of knowing if it is moving or stationary. In fact, to them, all that matters is that they are standing still. In our example, the bystander outside the vehicle will always be in an inertial frame of reference since he or she is standing still, i.e. at rest. For the passenger, it depends on the vehicle's movement. Let's assume the vehicle is moving in a straight line. If the vehicle is not accelerating, the passenger is in an inertial frame of reference. This is because no acceleration means your velocity is constant. If the vehicle is accelerating, the passenger is now in a non-inertial frame of reference. Continuing with the same scenario, try and put yourself in the role of that passenger. From your perspective in the vehicle, you are standing still and nothing is acting on you, but you experience what feels like a force pushing you in the opposite direction of the vehicle's movement. You're probably familiar with this feeling. It's that feeling of being pushed back into your seat when a vehicle first starts moving or accelerates quickly.